So today we are going to have another session on how to train your model in an ML pipeline using GitHub Actions. That's a very good serverless approach. It's a very nice and approachable solution. If you don't have any Google Cloud or any Amazon Cloud or any other virtual machine or a local Unix box, and you still want to train your model and want to see how your model is performing with respect to the predictions and the outcome of it, and you can go serverless. You don't have to have anything for you except a GitHub account, a valid GitHub account. So I'm not going to go into the details of what is a GitHub action, what is an ML pipeline. I hope you already know it, but if you still don't know, you can still have a basic session on that one. But the real purpose of this particular video is to show you how you can train your model in a serverless way using the power of GitHub. So for that purpose, let me show you what I have in place right here. So you can see here, this is the path where I am going to keep my model, that is the GitHub ML pipeline demo. This GitHub repository I'll also share in my comment section or in the description section. You can go there and check this link and go inside it. So basically when you come down, you can see this GitHub ML pipeline demo. You just go inside it. You will see the model here, the model.py. This is a Python file where basically I have created a TensorFlow logic or TensorFlow code to train my data set. It's only the data set is nothing here. It's just simply some iteration of numbers. I am dividing those numbers into 80-20 ratio, like 20% for testing, 80% for rest 80% for training, and you can predict some of the data in that case. Then what happens, I'm not going to go deep inside the core of it. I'm just dividing my data set into taste, train, and then I'm doing some predictions to check what is the performance of my model. And this one, the whole pipeline will run in a serverless way. This will not run on any server basically right now. So okay, so let me just go through. You can go through this code if you want to have some understanding of it. Basically the purpose of this code is to give you an output in the form of that it will train your model, it will perform some validations, it will test the fitment. In the form of the output, it will commit as mean absolute error and mean square error. So basically this data I am putting it inside metrics.txt inside my code. So these values will tell me what is the performance of my model, and if it is like not in appropriate way, then I will decide whether I need to train my model again or I can deploy the model, and then we can do the predictions on top of it for the real production environment. Now I have shown you the code. Let me go back and show you what modules I'm using inside my code. So these are the three modules I'm using. So I will go detail about matplotlib in the further part of it, but just give you an initial hint. It's like I'm plotting all my test result, prediction results, and train results in an XY scale, basically in a graph. And then I'm doing some calculations on NumPy, and basically all my predictions are getting created with the TensorFlow open source module. So that's how I have created my module here. So this is the requirements of txt. Basically all the pip installs which I need to do in my serverless, even though if it is serverless, still requires some modules to get installed before you can start performing your model training, right? So that is the purpose I have kept it inside requirements.txt and model.py. Now what happens if suppose a data science team creates a new model? What is my role here as an ML engineer? I need to just deploy it, or I can ask the data science team, you just go and upload your model inside this path, and then it will automatically train and deploy it accordingly, basically. So I don't have to again go manually and do all this stuff. It is like event-based kind of thing. It's an event-based trigger where I don't have any role to play. Data science team can independently do it. Now what happens, this is the YAML file. This is the GitHub Actions which I have created here. Now this GitHub Actions, if you go inside here, CML GitHub iterative, you just Google this part here. When you go here, you will see this link, and this link will basically uh, this will give you the continuous machine learning part which is provided by GitHub. Basically, this will give you all the functionalities, like you can evaluate your model, you can train your model, you can also go in the details of it, go down, you can see this is the standard YAML file which GitHub is giving to you, and you can modify it according to your own use case. If you are going to train your model in a very containerized approach, you can have your images in your private repository or in a Docker hub or public repository, and just use that container to train your model if suppose some specific environment you need to create. And this if not, then also you can train it without any containerized approach. And this ones are very important. This is the CML functions provided, like if you want to publish some of your metrics, you want to send it as a report.md, or any kind of visualization approach, you want to send it on mail to your team members, then you can use this functions, and I'll show you how I'm using it inside my code. So I have already prepared my YAML file based on that particular same example provided by GitHub. So what I did, I just copy pasted this particular part, okay, and I changed only this part, and rest all can remain same, and you can change the name whatever you want as per your meaningful name you want to keep. Then I will go here. This is the one I have right now here. You can see the YAML file, and this action will get triggered only when someone does any change or pull request happens to this path, that is GitHub ML pipeline demo path. This is where I've kept my model.py. Any pull request will happen, then this event will get triggered basically, and this is the name I have given, like train my model. And then it will go inside that path after it has get cloned basically in that serverless environment. It will then do a pip install of all the requirements I had shown you earlier, like NumPy, TensorFlow, as well as your matplotlib. And then you will just simply run the model TensorFlow Python code. It will train the model basically. That's what the core logic lies into. And then I will publish that metrics. If you go inside my code here, you will see I am publishing the mean squared error and mean absolute error in a metrics.txt file. This metrics.txt file, I need to show it somewhere, right? So that is where this part will come in handy. This part. This is where I am going to echo the report.md and then cat basically this value of mean absolute error and mean squared error, which will give the performance of my uh, fitment of my model will come and show up in the report.md, and then you will come to know how my model has performed. And after I have put it in the report.md, I have to send it across to my team members, right? So then I will use this CML send command. As I had shown you here, they have given this exclusive functionality in the continuous model machine learning module of GitHub, that they have given this functions. You can use these functions and send this report to your team members in a mail. So let's kickstart. So I will create an event now. How will I create an event? As you remember, in my GitHub Actions, I have created the event based on my pull event. Basically, the pull event will only get triggered when I make any pull request inside this particular folder basically. And suppose right now I want to trigger. So what I will do here, I will go into this. I will just create a pull request. I don't need to change anything right now in my code. but still I will make some small change. Just I can say like epochs, I can make it as 25. I will pass 25 epochs for my train data set, and that is how I will create a pull request. I'll just change this meaningless part of the code, but let's see here. So I'm going to create a pull request here. Let's just uh, dummy one. It will create a patch branch basically. I can delete it later on, not an issue. So I'll just create a temporary branch. I'll propose the changes. It will show me and it will ask me to create a pull request to get it merged to my main branch. This is where my event will get triggered. That is important, main branch. And then I'll create this pull request. So now after I've created this pull request, I will merge my pull request. This is very important. I have to confirm these are the two steps. So merge has happened, completed, and then I'll delete this temporary branch which I had created for generating a random pull request. Now, if I go here in my actions, you can see something is running here. There's update model.py. This is the label I had given when I was creating a pull request, basically, or a message I had given. You can give it a meaningful name, but let me show you what's happening inside. So you can see the containers are getting created because in my GitHub action I am doing containerized training of my model, and that container is getting set up. Okay, so it will take some time. Let it run. Okay, so it has started doing that pull, basically pull policy. Basically the Docker is getting created, the image. The environment is getting set up. It will also perform some pip installs. Okay, it has done. Now the TensorFlow model is running. Okay, great. Okay, so it's going on cool for now. Okay. I wish I could fast forward this one. If you want, you can skip this part. You can just go and skip to the few seconds or 1 minute would be enough for you to skip. Okay, so it has performed 25 epochs. Okay, now it's stopping the container. It's cleaning up the whole serverless thing. It will basically clean up after that particular part has completed, so that the server is not consuming that space again. And then if I want to see what has happened, I should get a mail with respect to my mean square. Okay, I got a mail. You can see here GitHub Actions has sent me a mail through a bot. This will give me an information which I had given in the metrics.txt, right? So that cat value is there. So mean absolute error is 46.91 and mean square error is 2230.67, which is like I don't think it's good, but still I will improve on that one. How will I improve on that one? Let me show you how. Now again I will go to my code, and I will this time I will show you some magic in the terms of matplotlib, because that's a very cool feature where I can show you in a graphical way that how my model is performing. Numbers won't show you the things, because if you are like a person who is more into graphical representation of his metrics, then that will be a better approach. So what I will do here is I will increase my epochs basically, or I can create another dense layer. Basically I will also create another dense layer here. Okay, so that one more neural layer has been added, and I am going to change the epoch to 100. Now it will train a lot extensively. And okay, so I don't also want to show you, I'll just not change this now. What I will do, I will change my workflow. Okay, what I will do here, I will also show the mat.lib, right, as I promised you earlier. I am just going to keep this thing. I'm just going to uncomment this part. Okay, this is an important part. This one, this part, this is where my mat.lib will publish in the form of an image. Now, how this image is coming, I'll show basically. First, let me just uh, see if there is any error in the code. No, there is no error in the code. So GitHub Actions, create it. It will not perform anything unless and until I create a pull request in my actual code of model.py or anything in this folder, GitHub ML pipeline demo. Okay, here I will make my main changes in the code logic. I will create, as I did earlier, I will again add a dense layer, neural layer basically, to make my predictions more effective, more closer to the prediction. Prediction should go in a right way. Epochs, I will train it more extensively, like 100. And one important part here, I will uncomment this plot predictions because earlier I had committed. So that is the reason you did not see any plot predictions. Now you will see the MSE and MAE in the form of a graph. Here I will create a pull request. Okay, I'll again create this temporary branch. Okay, now I will change the name. What I will name it as train model demo with matplotlib graph. It does not require to be like, I don't know why it's giving red, but it's fine. Okay, so now I'll create a merge request. Then I will delete this temporary branch now. Now I don't want merge. Okay, so you can see the name has changed. The name is like train model demo with matplotlib graph. It will again perform the same thing with a latest feature which I'll show you when I will complete the model training. It will show you now with a graph with all the predictions, trainings, and test results plotted in XY graph basically. So cool, container is getting pulled. You can create your own container. I just want to reiterate this part. If you have some certain requirements of some certain uh, uh, images you want to create, you can create a node container and keep it in a public repository or a private repository and can create your own code inside this GitHub action. Okay, so pull complete is happening. A lot of things will get installed. The Docker will always consist of Python and so many things. Okay, so TensorFlow has kickstarted. This time I want to show you this magic. Cool. You can also skip this part if you're not interested in seeing the logs. Okay, the epochs has been completed. Okay, you can see the mean square error and mean absolute error has reduced very drastically. And this should give me a better performing model now, basically. Okay, now everything is completed. I'm waiting for the mail. Okay, so see what's happening here. Cool. Now you can see this part is here. This part is the purple ones are the training data set. The green ones, which is hiding behind this orange ones, are the test data sets, and this orange one are the actual predictions. And you can see it's matching up with what actually I expect to. So that's the result that my model is performing very good. And this is the mail I got. You can see it has given a good performance. So enjoy, folks. You can just play around and wish you luck.